Hello everyone and welcome to the class. And today I'm just recording the class. And for today's session, actually in the news, a student led discussion. It's not for today, but we're gonna do it in our next session. If anyone submitted already, we're gonna discuss that in our next class. And today the plan is to continue our discussion what we were talking in our last class, network design in the supply chain. And uh, actually in the last class we are talking about a problem, and that problem we kind of formulated in the Excel and haven't finished it. So let's go from there. So I think it's on the previous slide. So, yep. So this is the problem we actually were talking about. So what I will do, I will go back to the Excel and we'll start from there. All right. So we back to the Excel here. So just to recap, the top cell here until this basically represent the problem as we are talking in our last class. So the vice president of the Sun Oil, this is by the way from your book, the problem, a manufacturer of petrochemical product, and they sells worldwide. So the vice president of that Sun Oil company, he's trying to get where to locate the facility. So these are the market actually, North America to Africa, and every market has a specific demand which shows over in this cell, and these are in millions, and these are the cost in thousands, uh, and these are fixed cost again in thousands for different capacity. So to fulfill this demand, where they should locate the facility. One thing they can do, they can open in east of the location. I mean, one in North America, one in South America. Maybe all are with highest capacity with 20 million size. In that way, that will lower the transportation cost, but to open the facility, that will increase the opening cost. So there is a trade-off. How many facilities you will open? So this objective function to the right and subject to, I bring it here so that we can understand what we are doing here. So in the last class, we added, so these, whenever you are given the problem, you can add this cell anywhere. You can add in between this cell, but these are basically the cell what we need to find out. So these are your xij's, the decision variable from the right, how much you gonna ship from one location to other location, and the small and large capacity whether you are opening. And finally we are doing here this cell, basically we are summing up small plus the large capacity, and we just can drag it here because right now there is no facility was opening and all this cell empty, but we're gonna decide from the model gonna decide what gonna be the values. And in the last session, we added this, the constant about the capacity constant, and this basically reflect to the second one over here. So what you can do, you can either bring the xij and all those variable to one side and make it like either less than 0, or you can bring like what I have done here. I put like kiyi negative xij summation of all j greater than equal to 0. So I bring this xij to the right. So that's what you can see here. The kiyi, which is the capacity times the ACE4. ACE4 is basically the capacity, and this is your location like yi, and negative to your sum of all those xij's coming from here, like your North America to all those locations. So this represent that one. And then we have just drag it all others, but you can see here basically that represent the next one for South America and others. And these are for the demand related constant, which is the first one. So again, I bring like dij negative xij summation of all I equals I1 to n. That means how many market you have. Uh, and then that equals, I will make it 0 in the constant when I put into the formulation. So that's what we have just exactly done it, but it's you can do like xij minus dj equals 0 as well. But here you can see we have done like the first D is the demand, that is B9 cell, negative sum of all coming from North America to all other markets. And that again, this one. So now the last two are basically it's saying like all the decision variable opening yi can be 0 or 1. If you open, that's going to be 1. In other cases, it's going to be 0. So this is the variable we are trying to see which location they're going to open. And then the xij's like amount shift between either from North America or South America if a facility open in North America. So this is saying here it's always it's called non-negativity constant. So what does it mean? That xij can never be any negative values. Either it is 0 or greater than 0. And finally here we added the objective function. So objective function you can see here to the right, it's multiplication of all the opening cost with the decision variable. So with this is small times the fixed cost, and that exactly we have done here. You can see. And then finally the cost of shipment. I mean, this is the cost times whatever shipped you will be doing. And we are utilizing the sum product function. You can do one by one, but Excel has nice formula that you can utilize and make use of it. All right, so this was up to our last session. And now what we'll do, we're gonna solve this problem. And that's why I again, I'm gonna show you how you can bring the solver, as I already bring the solver over here. You can see whenever you go to the data tab, you can see solver over here. But if you don't see the solver, then you just need to go to the file and then in the option, you see here the ribbon coming with different ribbons, but we're gonna do add-ins. And whenever you click the add-ins under manage Excel add-ins, we're gonna add, we'll click go and we're gonna add this solver add-ins, and you're gonna check mark this one and you hit OK. Then whenever you go to the your data tab, you will see the solver, and that we're gonna use from now to solve this problem. Solving means this how much quantities is gonna shift, because right now 0 quantity. If I say let's say 6, then you can see your cost gonna be values, and there is some excess capacity, but this we would like to solve it. I just put a random number. You can even put like different number and see what's gonna be the cost. You can see 595, and if you open a facility, let's say here to the euro, then you can see this is your total cost. But we're gonna see what model suggests. Model suggests means what is the optimum cost. So let's click the solver button here. And here, this is quite interesting. So what you're gonna see, whenever you click the solver, you will see it says set objective. So objective is, you remember, this is our objective function. So objective function, you remember that exact equation, we put it in this cell number B31. So I click into this cell and I make a cell reference of B31. And then what we are doing here, we are minimizing the cost. So that's why we select min. But if it is a maximization, you can choose max. But in this case, we'll do minimization. Excuse me. And now by changing the variable cells. So variable cells means your yi and xi. What are the unknown you're gonna trying to solve? And the unknown are yi and ij's. So where those we are referencing? Those basically, okay, you need to select inside and just make the cell reference from all selecting from B14 to A18. If you have multiple cell, multiple places, then you can hit comma and select all the cells. But this formulating, it's up to you. You know, these are the thing you are trying to solve, and you can put this cell anywhere. So we have objective and by changing variable. Now the thing is, we have to add all this constant. So what is the first constant? So to add the first constant, we have xij equals dj, and you remember these are related to this cell B28 to all these cells. So let me move up here so that you can see both. So I select inside and click add, and then it says cell reference. So my cell reference here, you remember we bring this xij to the right, so dj minus xij, so that equals 0. So this cell is the portion dj minus xij. So I select that one, then it's gonna be equals, and other side gonna be 0. So this B28 represent dj minus xij again, and I hit OK. So this is gonna giving me the first constant related to exactly this one. Now we are ready to add this constant, and this is related to capacity, and we have all these cells here from B22 to B26. Again I hit add, and if you recall, we make kiyi minus xij and make it greater than equals 0. So that exactly one will do, but you can do like xij less than equal kyi. Then you can formulate that way here, these values. But we put like kiyi minus xij greater than equals 0. So whenever I select that one, then I have to change this greater than equals 0 and select OK. So far we have added two constants, and now we have to add all this last two set of constant. So let's add that, select add, and let's add this yi element 0 1. That means they are binary, either 0 or 1. So what are those decisions? Selecting yi, these are small or large capacity. From this cell to this cell, I just make the cell reference. And here for the 0 1, you can make it a binary. So this is integer, binary, and difference. So I would like to make it binary, either 0 or 1, and select OK. So we added 3. Now the last one is xij greater than equals 0. And that you can make it by clicking again add and make the cell reference up to this one from B14 to F18 and select OK. Oh, sorry. You see here I forgot to add uh, the value to the right. So we are doing like greater than equals 0 and select OK. So we added all the constant and variables and objective function. So now we have to make the later half selection. So, this problem is an optimization problem, and to solve it, there is a renowned solution technique called simplex method, simplex linear programming. That's why it's here it's saying simplex LP, but it's not a nonlinear problem or evolutionary problem. But we're gonna use it is a linear programming model. We're gonna use simplex LP. Uh, this is an iterative process. You can take a look, but that is out scope to the course. So I'm not going to talk about the method, but we're going to utilize the method here. So I select the simplex LP and hit solve. So whenever I hit solve, then you can see there is all the changes are happening here. And if we select OK, and this is going to be giving us the solution. All right, so this is the result we got. But look here, there is something wrong here. Uh, there is no facility actually open. We have also some cost and only like 12 unit from Europe to North America, but nothing is showing here. What does it mean? There must be some wrong. Let me take a look into our formulation again. All right, so over here you can see. So we have make only one cell reference here. You see, this is the case here. It's both for this constant and this constant for demand and also for the capacity constant. So you can see we only make the reference B28, which is this one, but we haven't make all this cell B29 to till Africa. So what I'm gonna do, delete this one and add a constant to that demand related. So this is basically this cell B28 to F28, and you remember this is related to the demand, so which is equals to 0, and then click OK. And we're gonna do same for B28, sorry, B22 to B26. So again, I'm gonna delete this one and click add and select all this cell should be greater than or equal to 0 and select OK. So now let's take a look. I think now the problem is formulated correctly. Let's hit, so make sure you select simplex and solve it. And keep this solution. If you select answer, by the way, it create another cell. So this is basically now look like we got the solution over here. You can see here, basically the model is suggesting not to open any facility to North America as those two are 0, who is small or larger. But in South America, there is a large capacity model is suggesting to open. In Asia, there is one large, and in Africa, one large capacity based on the cost given here. And then these are the number we now got, like it's suggesting from from South America to North America, 12 million demand gonna fulfill, and then the remaining 8 gonna fulfill the demand of South America from South America. And you have another facility on Asia, so Asia is fulfilling Europe's 4, and then Africa is fulfilling Europe remaining 10, which makes total 14 million demand. And the 16 demand for Asia is coming directly from Asia, and Africa's demand 7 coming from the 7 of their capacity. So with that, we basically solve this problem. Now, I would like to give you some challenge question of this problem, and that I'm gonna upload as a task. So, uh, what you have to do, let me write it down here. So there are three tasks. You can do each task in different tab. For instance, first tab for first problem, then you can copy the same problem to other cell. But let me tell you the task. So the first task, let me write here, uh, task one, to solve this problem, actually, what I have done here. Solve this, solve this optimization problem. This is an optimization problem. And then the second task, some alternative scenario I would like to ask you to solve. And the scenario are, what if a plant must be built? Right now, there is no facility opening in Europe. So I want you to force the model to open a facility in Europe. So that's why, what if a plant must be built in Europe? So you have to think about to adding a constraint. You remember all the constant you have added, so you have to think what constant you have to add so that a facility must open in Europe and fulfill all other requirements. And the task 3, uh, I want you to think, what if, let's say, what if, let's say, if all the facility, all the location, if plant are open, if plant must be built in all the, like every market. That means I want to open a facility in, I don't care whatever the capacity, but I want a facility in North America, South America, Europe, Asia, and Africa. So you have to think of what type of constant you have to add. And for each of this task, you solve it. For instance, the first one is in this tab, then you can add another tab for, let's say, you write like task 2, and we copied over the first portion, then you solve for the task 2, and task 3 is basically for the third task. So you solve those 3 and submit it to the model. So that's pretty much for this problem. And now we're gonna move it. We all are talking about last class session, and now we're gonna move to our today's session. So let's go back to the PowerPoint. All right, let's continue our lecture. So as we are talking about, so in our last class, we talked all these first 4 section. And today we're gonna continue our discussion from discussing optimization model to identify the potential site in a region. So this is, you can think of, uh, you are basically identifying the potential location that you identify those potential. At first, you remember in the first cases, we identify the network design in a big picture. So now we are identifying from the big picture region to potential location. Where exactly is region the company has to decide to locate a plant, and that is doing in the model for identifying potential site, location site. And one of the method is used, gravity location model, for identifying suitable location within the region. Uh, and then the last one is network optimization model to locate the plants and allocate market demand. So this is kind of similar to the first one, but in this case, I mean the first one on the Excel we just saw the problem, but in this case, you're gonna decide more like a specific location. For instance, this is another problem. You can see here in this problem, uh, this is basically two manufacturer of telecommunication equipment. One is Telecom One and another one is High Optic. So they have different location, and for instance, Telecom One has focused on the eastern half of the US, whereas the other one in the western region, the High Optic one. So for the Telecom One, it has manufacturing plant that located in Baltimore, Memphis, and Wichita, and it served the market in Atlanta, Boston, and Chicago. So these are the market for the first one. And the second one, High Optic, that has target the western half, as I said earlier, and served market in Denver, Omaha, and Portland from the plant that located in Cheyenne and Salt Lake City. So now this problem, you have actually also given the cost is very similar to the first question. Now this problem, I'm going to show you directly the problem here. So the first problem is to identify, here is given like the location already located. You have to allocate the demand. That means the Xij. So the problem I showed you in Excel, that just you remove the location part, that if the facility on and off decision, but you have to decide how much you're gonna ship. And you can see the necessary constant. One is demand and the capacity constant. And this problem also, this is for instance, this is the solution for those two cases. It's better to talk in Excel this problem. Let's go to the Excel spreadsheet and talk about this problem. All right, so we are back to the spreadsheet here. So as we are seeing into the PowerPoint slide, this is the problem basically. As I said, it's very similar. So here I have multiple tabs. The first one is solved for the problem I already formulated. So you just need to solve it. For instance, excess capacity is very similar. I added as it's coming from Cheyenne and Salt Lake, and it's serving the market in Denver, Omaha, and Portland. So the facility is already located here. So in this case, so you are just allocating this Xij's decision in the highlighted. So now the excess capacity constant here and the demand unmet, and this is the objective function. What you need to do is you go to the solver and you add the constant and solve this problem. So the constant gonna be one of them gonna be this one. Obviously, by the way, the objective function is this one, B32, and by changing the variable is basically from E15 to the 16, and then all the constant. Likewise, I showed in the earlier problem, you add excess capacity and this unmet demand, and non-negativity and non-negativity. There is no binary restriction constant because we are not locating the facility. And for the second one, the telecom one, you just solve it for the other eastern part of the country, Baltimore, Memphis, and Wichita location to these other market, Atlanta, Boston, and Chicago. And then you basically solve here for combining all these market where already facility is located, and you decide all the market together and then solve it. And finally, this one where you not only locating the like deciding the how much gonna be transport, but also the facility location. For instance, here in this case, we already consider the facility is there for high optic and telecom one. The facility is there in those three locations. But in this case, it's saying you have to locate the facility. So this problem is exactly the same problem. We solve it the first for the design problem. So you add the excess capacity constant here. You connect with uh, the facility and the capacity. But other one you can see the capacity is not connected with the facility, basically opening decision because the facility is already opening. And you can then compare the cost, in which cases the cost is lower from this exercise. So I'm going to upload this. You can do the exercise. And now let's go back again to the PowerPoint. All right, so in this PowerPoint, you can see the optimal demand allocation for telecom one and high optic. When you solve it independently, only allocating the demand, you will get the solution, like how much gonna be shipped from each location. In this case, for instance, you can see even though you located a facility in Wichita, but there is nothing shipping from that. So which is basically unnecessary opening cost. And you are basically shipping from Memphis to Atlanta, then Memphis to Chicago, and then Baltimore to Boston and Chicago, and fulfilling the demand. Moving on to the next one. Oh, so these are actually existing production facilities again, what we have seen in the Excel. Let's continue. And there is another variation of the problem. This is very important problem in optimization for facility location problem, where not only you can locate one plant, but also you can incorporate the warehouse location or even the downstream any other facilities. You just need to add the corresponding term to the objective function and the constant and the flow between flow constant. So for instance, here, the supplier and market, and you have potential plant and warehouses. You are locating those facilities. Maybe you have the cost. Then you can formulate the problem and get the solution. And with that, basically that's all for today's session. But I would like to talk briefly about an assignment problem, uh, which I'm gonna be uploading. So remember, for the first problem, I will give you 3 task problem that gonna due in next Wednesday. And for the assignment, it's gonna due on the Friday. But um, I'll talk actually, let's talk on the class actually, that one. So that's all basically. Thank you very much.